Hello and welcome back. We have left off in exercises traits 1, and as usual a small introduction. What are traits? So basically traits help you to define shared behavior between your complex types. So as you can see here in this example, which is very good, we have a struct circle that has 2 points, x and y, and it has a radius. And then we have here a square which also has x, y, but this one has side instead of radius. So what they both share in common is they basically have an area. So instead of implementing like you did before in a struct methods, we can create a trait which we will give a function signature, and as you can see this is only the signature, so we don't open here curly braces and define basically the function. We are just passing the trait a signature. Then what we will do is we implement this trait has area for this type circle. What we then have to do is we have to define the function which is in the trait. So we implement this trait has area for circle, and then we have to take this function signature and basically define what this function will do and what is the output. And of course over here we have the same thing. We implement has area trait for square, and then we take the function signature from the trait over here, and we basically just define what the calculation is and what is the return type. For this example we have here two floating points which gets multiplied, and here we take side times side. So a square, basically to calculate the area you just multiply side by side because all sides have the same length. And yeah, and then we basically just print out shape area. Shape, as you can see, is a generic type. We have defined that here, and it implements the trait has area. So this generic type actually has to be implemented has area. For example, square, for example, circle. They both implement has area. If you pass a type which didn't implement this this trait has area, it will give a compiler error. And then what it basically does, it will accept this type which has implemented the trait, and it will just call the area function. And as you can see, every trait that has implemented has area will have this function. So basically that's why we define over here that it has to implement the has area trait, because this makes sure that it has the area method. And then as you can see, we can here have a circle and make an instance C, and we have a square S, and then we just call this function print area, and basically it will just print the result of the calculation. So for example, just very short, we pass C, which is of type circle. It has x, y, radius. Or let's say S, it's a little bit easier to understand. We pass s, which is of type square. It will go over here to the print area. Now firstly it checks, has this type square implemented has area? In this case it has. Over here has area is implemented for square, and then it takes the instance s and it calls area method on it, and all this does is basically it multiplies this times this, so times side, which will be 0.1, and it returns it, and then it will get printed out. So that's basically traits. So let's get into it. Your task is to implement the trait append bar for the type string. The trait append bar has only one function, which appends bar to any object implementing this trait. So as you can see, we can even implement traits for standard library types. So string is actually a type from the standard library, and that's pretty cool because it gives you a lot of freedom to then modify the behavior of these types. So as you can see, we have a trait append bar, and it has a function signature append bar self, and it returns self. So as you can remember, self is basically the instance the method is called upon, and self basically will be string, because self refers here to string. And then we have implement append bar for string. So here we are actually implementing this trait for the type string. Then in the main function, we create a string from foo, and store it into the variable s, and then we call this method, which we have to implement over here, append bar, and then it prints out this modified string, and this modified string should then be in the end foo bar, like that. And the second test, as you can see, we don't pass anything, and then append bar 2 times, so it should return bar bar. And let's go over here, and as I've said, basically in the trait you just define the function signature. Of course there is default implementations, I will come to that, but just for now think of it that you here just describe the function very briefly, and then when you're implementing it for the specific type, you will have to define it. So basically we just copied this over here, and then we can basically start with modifying the array. So here there are 2 ways. As you can see, we have self, and self over here is basically this. Self always is like a placeholder for the instance. So this here s will be self. So what we can actually do is we make a format like that, and then we take self over here and we append bar, and that's basically it. And don't put semicolons over here so we can return it. Let's see. As you can see, it's working. There is also another way. We basically just take self and then the plus operator, and we append bar to it like that, and it should basically be the same thing. Now, when you use this, you have to remember that any argument you pass after the first one has to be a reference. The first one has to be an owned type. So self here is owned. We don't have a reference like that. This is owned. And then what this basically does is it modifies it, it appends bar to it, and then it returns the string again. And that's what we have then stored in here. As you can see, string. So that's basically it. And we go to the next one. Your task is to implement the trait append bar for a vector of strings. To implement this trait, consider for a moment what it means to append bar to a vector of strings. No boilerplate code this time, you can do this. As you can see, we have here a trait append bar. It has the function signature append bar. It takes self as owned value and it returns self, which will be then vector. And as you can see here in the test, we have a vector of string foo, and then we append bar. So what it then should do, here we pop it 2 times, so the last element will be bar, and then the first element in the vector, let me just, we have a vector, and it basically should be like that after calling the append bar method, like that. And then we pop this one and we return that. So then the vector will look like that, and then in the end we pop like that. Foo will also get popped, and we basically have an empty vector like that. So to do, add your code here. So we implement append bar for a vec of strings like this. And then again we have to here define the function. What will this function or what will this method do? And all it does basically, and it's very important here that this has to be mutable. So we have to change it over here and over there, like that. This has to be mutable, so we can basically modify the vector. If it's immutable, we can't modify anything. So we take self, we push string from, and we push bar like that. And then what we do is we basically return self. All right, this isn't working. All right. Now, of course, we had here self, which doesn't need to be mutable, but over here, because we are actually implementing it for a vector, it has to be mutable, like that. But in the function signature, you don't have to define that. As you can see, let's see the patterns aren't allowed in functions without bodies. So here we can't have a pattern. Here we can't have a pattern, but here we can basically do it, because here this function or this method doesn't have a function body, but over here it has, so we can apply patterns over here. All right. Traits 3. Your task is to implement the license trait for both structures and have them return the same information without writing the same function twice. Consider what you can add to the licensed trait. As you can see, we have here a public trait license, and it has a function licensing info, and it takes a reference to self and it returns a string. Then we have two structs, some software, other software, and both of them hold a member version number, but this one holds an integer and this one holds a string. And then what we have here is we are implementing this trait licensed for some software and for other software. And then what we basically have is the test over here. So we have some software instance with version number 1, and then other software which gets an instance other software with this string. As you can see, some software integer, that's what we have over here, and other software takes a string as version number, and that's what we got over here. And then basically some software licensing info should return some information, this string over here. So what you can basically do is, don't edit this line, but I will just show you. You can basically implement for the two the same thing. So you can then here licensing info self. So what you can do basically is you can do it like that and then just define these two functions. But that would mean you have a duplication in your code. So you have to declare it for that and for this one. But it would be possible. So let me see. Basically what this returns is just a string from some information. Is that right? All right, some information. And here basically we have the same thing. As you can see, it's compiling, but this is not what we want. We have here basically 2 times the same exact code. And this will add a lot of boilerplate in the end. So what we can actually do is define here a default implementation. So this trait then has a method, and every type that implements this trait will automatically have this method without us doing it over here. So all this basically does is string from some information. And that's basically it. As you can see, we are just returning a string over here. And yeah, you can see we did it one time and it's implemented for these 2 types. And if we had another type, we can just write implement license for and then the name of the type, so we don't have to repeat ourselves many times. Alright, traits 4. Your task is to replace the question marks section so the code compiles. Don't change any line other than the marked one. Again, we have a public trait licensed. It will return some information. That's basically what we've implemented in the last exercise, and returns a string. Then we have two structs, some software, other software, and then we implement the trait for these two types. You may only change the next line. So here we have a function compare license types. It expects an argument software and software2, and it returns a boolean. So here it just compares software licensing info. Is it equal to software2 licensing info? And of course, here we have an error. Expected one argument found 2. So and as you can see, this should return true and this should return true. So what we basically have to do here is just, I will show you that in the book. So when we have a function signature, traits as parameters, it's that one over here, then you can actually pass traits as parameters. As you can see here, we have a function item, and it expects here any type that implements summary. But we have here to write implement summary. And of course, that's a reference. It doesn't need to be a reference. It can be an owned type, but in this case, it's a reference. And what this basically says is item is of any type that implements summary. So what we can do over here is just implement license, and the next one too can say implement licensed, like that. And as you can see, it's compiling. So what we basically have here is we say software, this argument is of type is of any type that implements licensed, and software2 again, it's of any type that implements licensed, like that. And then it just checks, because as you can see, we are here calling upon software this method licensing info, and software2 the same thing. So we have to make sure that these two are of type license, so they have this method. If we pass it any other type which doesn't have this trait implemented, it doesn't have necessarily this method. So this is important that we here define that we want a type which actually implements this trait. And then it basically just checks, are they equal? And they are of course equal, because they share the same method and it returns the same thing. So we have here some information equals some information, and this will return true, of course. All right. And the last one. Your task is to replace the question mark section so the code compiles. Don't change any line other than the marked one. So again, we have a public trait, some trait. This is some function, and all it does, it returns a boolean. And we have other trait, other function, and it also returns a boolean. Then we have two structs over here, some struct, other struct, and we implement both of these traits for both of these types. So for example, implement some trait for some struct, other trait for some struct. This is the first type, and then for the second type we also implement the two. Now over here you can see you may only change the next line. So basically what we have here is a function, some func, and then it takes item. This one we have to define. It takes item and it calls upon it some function, and then on the second one or not the second one, we have item, it calls upon it some function and then other function. And this should return true because both of them will return true. So basically all we have to do here, or before we do that, we have to define here a generic. As you remember, we here define generic t, and we define the generic t to be of type, of any type that implements some struct, and not some struct, some trait and other trait. Like that. So we basically say here the generic type t is a type which implements some trait and other trait, and this applies to both of these structs because they have implemented the two traits. So we define here the generic type has to be a type which implemented these two traits, and then item basically will be of type t, our generic type. And as you can see, this is compiling. And then, as I've said, it takes item, for example, some struct will get passed. This is an empty struct over here. We pass it over here, and then some function will be called, which will be this one, and other function will be called, which will be this one, and as both of them return true, this will be, or this will return a boolean of true. All right, that's it. Our next topic will be another quiz. So see you then. Goodbye.